Hello and welcome to another GCSE revision video, and in this video we're going to be looking at graphing quadratics. Quadratics graph into a parabolic curve. Now a parabolic curve is a U-shaped curve which, if made from a reflective material, can reflect light or sound or whatever it's supposed to be reflecting into a focal point. This makes parabolic shapes extremely useful to build telescopes or satellite dishes. The simplest parabolic curve is just the graph of y equals x squared. It's symmetrical about the y-axis, it's U-shaped, and it intersects the x-axis at x equals 0. Now, it's U-shaped, it looks a bit like a smiley face, and if the x squared term is positive, then you will see this curve that opens up at the top. I like to think of it as positive people are happy and they put a smile on their face. So if you have a positive x squared term, your graph is going to look like a smile. If the x squared term is negative, however, then your graph is feeling sad, so it's going to look like a sad face. So a negative x squared term opens up at the bottom, whereas a positive x squared term opens up at the top. If the x squared term is multiplied by a coefficient that is bigger than 1 or smaller than negative 1, then the curve becomes much sharper. That is to say, the slope of the curve becomes more steeper. If the x squared coefficient is smaller than 1 or bigger than negative 1, then the slope of the curve is shallower. If there is a purely numerical component to the quadratic equation, then that dictates the y-intercept. If the graph looks like a smiley face, that is to say if it opens up at the top, then it will have a minimum point. If the graph opens up at the bottom, that is to say if it looks like a sad face, then it will have a maximum point. Another word for either the minimum point or the maximum point is vertex. If we start with any old generic quadratic equation and we start to complete the square, when we get to the point where we have factorized the perfect square, the value for x that turns that perfect square into a 0 is the value for x that is the x-coordinate of the vertex, and the number that's left over that doesn't have any x's attached to it will give us the y-coordinate for the vertex. So in the case of x squared plus 2x plus 6, if we start to complete the square, we can put it in the form of x plus 1 squared plus 5. X plus 1 squared will be 0 when x is negative 1, and the x-coordinate of the minimum point is x equals negative 1. The 5 that we've got left over tells us the y-coordinate of the minimum point. When we have a quadratic equation in the form of x plus something squared plus something else, we call that vertex form. If the curve crosses the x-axis at any point, we can find those points simply by setting y equals to 0 and solving like we would a quadratic equation. Okay, you should now be empowered to sketch any quadratic equation you like. Why don't you have a go at sketching y equals x squared plus 2x minus 3. Go ahead and pause the video and I'll give you the solution at the end. Okay, how did you get on with that problem? Okay, let's have a look at the solution here. We've got our question is to sketch the graph of y equals x squared plus 2x minus 3. Okay, I'm going to try and draw my axes here. If I can get a straight line. Okay, so I'm going to mark off my points as well. Actually, I won't mark off my axes until I know where the interesting points are. So let's do a few calculations. Well, first of all, we know that the y-intercept is going to be at y equals negative 3. So the y-intercept is equal to negative 3. Okay, so let's go ahead and start completing the square. We've got y equals x squared plus 2x minus 3. Now, if we halve that 2, it becomes a 1, and then 1 squared is 1, so our perfect square would be y equals x squared plus 2x plus 1. So that's our perfect square. Now we've added a 1, so we need to subtract that 1. And then we've got our negative 3 here, which we haven't touched yet. So let's put that negative 3 in. So now this part here is our perfect square. So we can go ahead and factorise that as a perfect square. So y equals x plus, and then half of 2 is 1, so that's x plus 1 squared. And we're left with a negative 1 minus 3, so that's negative 4 or minus 4. So this is now in vertex form. So we know that when x is negative 1, this whole squared term will go to 0, and that would leave us with y equals negative 4. So we know that this x squared term is positive, so we've got a curve that opens up at the top, so we're looking for a minimum point. So the minimum point is equal to x equals negative 1, y equals 4. So if that's our minimum, y equals negative 4. So if that's our minimum point, we know that our y-axis only needs to go down to negative 4. So we can go ahead and put our y-axis on there. And then it can go up. And we know our 0 point is where the two axes cross. We don't yet know how to put the scale on our x-axis though. Okay, so to find the x-intercepts, we just set y equals 0. So 0 is equal to x plus 1 squared minus 4. So if we take this negative 4 across, we've got 4 is equal to x plus 1 all squared. So if we square root both sides, we've got positive or negative 2 is equal to x plus 1. If we take that 1 over to the left hand side, we've got positive or negative 2 minus 1 is equal to x. So either x equals 2 minus 1 or x equals negative 2 minus 1. So x is equal to 1 or -3. So now we know where to put, what scale to put on our x-axis. We need it to go up to -3. Okay, so our interesting points are our x-intercepts is at x equals 1, so that's here, and x equals -3, so that's here. We know our minimum point is at x equals -1 and y equals -4, so that's here. And we know our y-intercept is at x equals -3. So now we can just join the dots and try to join them in a U-shaped curve that opens up at the top. Unfortunately, I'm very, very bad at drawing, so this is going to look ugly. But hopefully we will get our intercepts right. Okay, so our curve should look like this U-shaped curve. Hopefully a lot smoother than that if you've got better hand-eye coordination than me. In fact, let's go ahead and see what the computer plots. And when we check those answers with the computer plot, we can see that the x-intercepts really are at x equals -3 and x equals +1. That the minimum point really is at x equals -1, y equals -4, and that the y-intercept really is at y equals -3. Okay, I hope that was helpful. Why don't you have a go at practicing some of those yourself? I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.